Hey there, welcome back to Raspberry Pi and Arduino serial communication. So in the previous tutorial, we basically saw how we were able to write a small code into our Arduino and send it to our Raspberry Pi. And then we wrote this quick Python script so that we can catch that serial communication and print it on our console here. As we can see, we are connected and we are printing CMTEQ, so that's basically what's being sent here. So this is my connection. So I've got the Arduino connected to one of the USB port that is basically TTY USB 0. Okay, so if you wanna catch up more about this tutorial, please watch the previous part. Now in this part here, we want to now send data back from the Raspberry Pi into the Arduino. But before we do that, let's first put all this script here into a single function so that we can be able to call it whenever we want to. So to do that, we will have to come into the new line and create your function from the new line there and give your function a name. So mine will be called receive data. So you can call yours any name you want to. Just make sure you remember your function name when you want to call it. So now I'm going to come into the script here and just copy or basically cut the whole script. And then we need to paste it under our function. So just Control V. So we paste it. Then you need to fix your indent here. So just select everything. Okay. Basically up to time there and then hit tab once, and then you just need to bring this one so that it can align. So now your indent have been fixed. Now let's try to run. Okay, now there is no problem. So the indent is correct. Now we just need to now be able to call this function. So now from here, in order to be able to call our receive data function, we need to create some sort of a dummy main. Just like in C programming, we have a main function. But in Python, you have to create a name for the main function and your program will be able to run from the main. And the way it is done is by writing if space double underscore name double underscore again, then is equal to, then you have your quote, you open your double quote, double underscore main double underscore, then you close your quote. Then you have your single colon and you hit enter. So basically from here, you can then call whatever function you want to run. So when you compile your Python script, it is going to start running from here. So to do that, let's just see, we're going to copy the receive data and we're going to paste it here. Okay. And now let's run this program and see if we're going to still print CMTEQ, as everything is still connected. So we should be able to get our CMTEQ if the program is running. There it is. So Arduino connected, CMTEQ. So we've successfully boxed our function, okay, our script I should say, into a function. Okay, so now we move on. So now what we want to do is I'm going to make a copy of this function, okay, and then the copy that I'm going to make, I will now rename it into a send data function. Okay, so that we can have both function for receiving and for sending, so that if we want to send the data, we can just comment out the receive data function, then we will just be dealing with the send data function. So I'm going to just edit this one here and say send data. Okay, so the only modification we have to basically do in this function is obviously into the while loop here, where we are actually doing the read line, because remember we are getting data being sent from our Arduino. So we can basically just remove that line of code there, and then we will have a new line of code that will be able to now send data from here into the Arduino. So the rest of the lines are going to remain the same, because we still need to initialize a serial communication and then send the data then we can still be able to interact with the keyboard, the data that we are sending. Now we come into the Arduino side before we write the code there. And also, please guys, if you find this tutorial useful, don't forget to subscribe to CMTEQ channel. That will be highly appreciated. And please like this tutorial, give it a thumbs up. Thank you so very much. So now in this part here on the Arduino side, we can similarly do the same thing that we've done into the Python code there. Basically just create another function, which is really not necessary because there isn't a lot of code. But we can nevertheless do that. Send data, okay, and we can just copy this. Yeah, so basically just that piece of code there, that is the one that we are using to do the serial print, and we are capturing it here with our Python. So now here we can then be able to write the code that will be able to basically receive the data that is coming from the Raspberry Pi. So we can put this function here since we are not going to use it for now. So let's just comment it out like that. So we need another function. Okay, so that function is going to do the receiving part. So we're going to say void receive data. Okay, right. And this is our receive data function, so we can just copy the function and paste it there because we're now going to use this function. Okay, there is our semicolon. Okay, now for receiving data function, we're going to write our code in here. Now, what we're going to write here is basically similar to what we were doing with the Arduino. With the Python script here. If I can just undo, let me just undo quickly. Okay, so you see what we were doing here. We were checking if there are data into the serial stream. So we check with the inwaiting, okay, function if it is greater than 0. So we don't know how many bytes that are being sent, the size of the data being sent by the Arduino, but we just check if it's greater than 0. That means there is something in the pipeline. Then we read and we decode it, and then we save it into the function my data. I mean the variable my data. So that's what we were doing here. Now we're going to do a similar thing into the Arduino from the Arduino side here, and that would be we're going to use an if statement, basically the same thing. So in our if statement, we're going to say if serial that available, so that is basically the serial data, if it's in there and it is greater than 0, okay, similar to the inwaiting, then we want to do something with that. So what are we going to do? We want to basically read what is being sent, what is inside that serial available. Remember, this is Arduino, so it's C++ C script that is embedded here, and a lot of things is going on. So these are already built-in function. Unlike in Python here, we needed to write everything ourselves. But here, the functions is already built-in. So this function is already going to be checking all the serial data being sent. Now we just need to read from this function. So in order to read the data available from the serial, we then need a variable that is going to be hold the data that we're going to read. So I'm just going to come here and I'm going to create a string variable. Okay, so that's a variable of type string, and I'm going to call it my data, right? Okay, so now we've got our string variable my data that is going to be holding our received data. Now what we're going to do is we're then going to say my data. Okay, so my data is equal to what? Is equal to serial, okay, dot read string. Serial read string. But there is only one issue with this serial read string here. So the data is coming from the serial, okay, but we are using the read string function to read them. Now this function is basically an Arduino built-in function. The only problem with it is it got like a 1 second timeout. So that 1 second is built in. So it will be waiting for 1 second before it actually assign the data into your variable. And that is to check if there are no other data coming. Okay. So one option you can use if you want to stick with the read string, you can include basically force the timeout from 1 second to maybe a couple of milliseconds. And the way to do that is, okay, we can just get rid of this delay here. So we get rid of the delay. So you just come here and then you just say serial dot set timeout. Okay, so the set timeout function will then override this and build timeout. Then you can choose whatever value you want to set here for your timeout. So it's normally 1000 milliseconds by default. Now you can put maybe 100 milliseconds. So which means there's still going to be a timeout. Even if you put a 1, there's still going to be a timeout. But there is a risk of losing data if the timeout is also too fast. Okay, so unless you know exactly what you are sending and there is no data of critical importance that can be lost, then you can maybe go with this way. But if you want to make sure that you don't lose anything, then you have to go with a different function here. Okay, instead of implementing the serial set timeout, you can then just change this one. So you can just change it by replacing it with a similar function. So that is serial read string until. Okay, and then you need to pass parameter into the until. So basically you're going to tell it to read string until it receives something. So it should also be a character. So you can just say it must read until it receives a new line symbol. Okay, so that is the \n. So if it receives a \n, then it must stop reading. It must basically just take all the data that it just read and assign it into the variable my data. But then you have to make sure that what you are sending is going to contain the \n at the end, so that it will read it instantly and don't wait for the timeout compared to the previous function that we wanted to use. So this is basically the fix for that. So from here, basically we will be able to receive data from the Raspberry Pi if the communication is indeed established. Okay, so now I'm just going to restore my 100 millisecond there just to allow the serial communication to establish. Okay, then I come back into my Python script. Now here, okay, let me undo. Okay, so this is basically what we were doing to receive the data. So I'm going to rather comment it out. Okay, and then I'm gonna basically, let's see, let me just be over the top here. Okay, so from here we then going to write data. So what data we're going to write is what we want to send from here into the Arduino, correct? Okay, so I'm going to declare or define another variable, and I'm going to basically just say data is equal to, and I'm going to just write the data that I need to send there, and you can write whatever you want to send. So I'm going to say data from Raspberry Pi. Then remember what we said. We must end our data with a \n, so that as soon as this function read the \n, then it's going to immediately stop waiting and then just assign the data into the my data. So we're overruling the 1 second timeout there. Okay, so we then have to include our \n like that. Okay, so now we can then take the variable that we initialize here, that is establishing our serial communication. We can then write the data into it. So we're then going to take sdata dot write. So we are now calling the write function so that we can write our data. So the data we are going to write is basically the data here, which is saying data from Raspberry Pi with our \n. Now we're going to pass the data into the function. Now, similarly, as we were doing here with the read line, and we needed to do a decode here so that we can be able to print and get the correct data being sent from the Arduino. But this time around, we're then going to encode it. Okay, we're going to encode it using the similar reference. So we're going to say data dot encode, open bracket, and then single quote. Then we're going to have UTF-8 for encoding. Okay, so basically the function is done. So let me just give this thing a try and see if we're going to get an error. I still have all my communications set up there. Okay, what are we getting? Arduino connected. What is happening here? CMTEQ, hi CMTEQ, let's see. Okay, we basically are still calling the receive data. We are still calling the receive data. What is happening here? Receive data. This is quite strange. We are basically still calling the receive data, and okay, it makes sense because we still have the previous program into the Arduino. We haven't changed that. We still have it. So let me see. Let's write this program into the Arduino. So we're going to see what's going to happen. Let's first write it in. Compile, upload. Okay, done uploading. Now we've got a new code. We don't have this code anymore that was printing hi CMTEQ, because now we are calling into our loop here the receive data, not the send data, got a hi CMTEQ. So now if we now run from the Python side here, we should not be able to get anything here. Let's see. You see, we just got Arduino connected, because we are just printing Arduino connected from the receive data. But now Arduino is no longer sending anything. Arduino is no longer sending anything. The communication is established, but we're not getting anything because we have a different function into the Arduino. Okay, so that basically means that part is working. So I'm going to just comment that out, and let me stop the function. And then here we then going to call the send data function. So let's just copy that. We copy that, and then we just come here and paste it. So basically the send data. Now let's run this one and see what is going to happen. Arduino connected. Okay, so we're still getting Arduino connected also here for the send data. That is fine, but we are now also getting inside the while true here. We are writing data, but we have no proof here that the data actually are being written into the Arduino. Now, let me just run it again. Let's observe. Okay, so let's give it a run again. Okay, what's happening here? Arduino connected, but we are not getting any sign of a serial transmission. Let me just observe it again. We should get some blinking here from the transmission and receive. Okay, so basically just when we are setting the connection. So what is happening? But I am sure we are inside this while loop here. Okay, I think our time slip is basically very short. That's why we're not seeing anything. Data are actually being sent. Now let's maybe increase this time slip here to, let's make it 1 second. Okay, so we make it a 1 second, and then run our Python script again and see if we're going to get a send data waiting. Oh, there it is. So the transmission is happening now. It's blinking every second. So we are transmitting data every second into the Arduino. Okay, so we can see that we are indeed sending, we are transmitting data because of the TX blinking there every second that we just set up here. So that is fine, but nothing is showing to us here on our console here that we are actually sending data. So in order to correct that, we can maybe just add another print statement there. So I'm just going to copy this one, and let's just put it right after there. So what I'm gonna write here is basically just a string, and I'm going to say transmission in progress. Okay, so we have a transmission in progress. So now if I run this now, we should be able to print transmission in progress every second. Okay, transmission in progress. There is a typo there in transmission. Nevertheless, it is working. So we have a transmission in progress. Okay, but now the Arduino is receiving the data. Okay, now if we take the function that is supposed to be sending data, or if we do a serial print, right? So if I take a serial print, I will just copy that guy there and put him there. And then here, I'm going to say my data. So if I put my data there, what is going to happen here? Let's see what's going to happen. So let's just run, because it's important to just see. Okay, so we are printing. We basically transmitting. The Arduino is receiving it, but now the serial is also printing the data into the line. But now we won't be able to receive that data because we are not computing this receive data function. Let's see if we call this function. Okay, this is now trying to play with hardware here, because we are using the same serial communication, so it's almost going to clash. Okay, so we are transmitting, but we are stuck into the send data. We are stuck in there. We're not getting out of there, because remember, we are using the while loop. Okay, so we are stuck in there. We're not going to get out of there, so there is no way we're going to actually access the receive data. So, but how are we going to be able to check that the Arduino is in fact receiving the data? So if I open the serial monitor, we're gonna have problem here. Let's see. Now the transmissions in progress is stuck, but we are not printing anything here. Although the Pi is still sending, but we're not getting anything because it's the same serial communication. Now if I stop this one and open the serial communication, and then I try to run, now there is a clash. You can see there is a clash because now the serial port is already open with the serial Arduino serial monitor itself, so Python cannot access it. So I have to close this guy here in order for me to do my transmission, which we already demonstrated in the previous tutorial. Now that the Python is already using the port, if I open here, I'm not going to get anything, and everything just sort of stuck. So now, how can we actually see that we are receiving the data other than just the blinking? So we can use an LCD display. Instead of using the serial print, we can do LCD.print. Then we can print the data onto the LCD. So in the next tutorial, I'm going to then implement an LCD display into this Arduino board, and then we'll be able to see the data that we are being sent from the Raspberry Pi to see that display on our Arduino, and also have our serial communication still running without any issue. So if you find this tutorial useful, thanks for watching, and gives it a thumbs up, and don't forget to subscribe to CMTEQ channel. Until next time, stay tuned for the next tutorial. Cheers.